Hi everybody, this video will actually be for 2 days worth of notes. This is going to be days 1 and 2 of our brand new section. So 4.3, day 1 and 2, Polynomial Division. I will be changing up the colors, so if you have a highlighter, go ahead and grab one so we can have the same types of notes. So the first thing we're going to talk about is our notation. So when we divide, let's say I had one function, I'm going to call that f of x, and I was dividing it by another function, we'll call that one d of x. This would be my divisor, and my result will be a new function. We'll call that q of x. This new function, this result of the division, is called the quotient. And if this did not divide evenly, we will have a remainder. We'll call that remainder r of x, and the denominator will be what you had originally divided by. So this entire piece right here is the remainder. Now, as crazy as that might look, that is the same as discussing something like 10 divided by 3. Here, 3 is the divisor, because we're dividing by 3. Well, what does 10 divided by 3 equal? 3 divides into 10 3 times, with 1 left over. So 3 is the quotient, and 1/3 is the remainder. It's what was left over. And if you notice, just like here the divisor is present here and then is also part of the remainder, notice here we were dividing by 3. The denominator of the remainder is 3, 1/3. So these two should really be seen side by side to help us appreciate what this vocabulary means. We have one definition to talk about before we get into our notes. It's the remainder theorem. The remainder theorem says that if a polynomial f of x is divided by a factor, let's say x minus k in general, then the remainder we'll call that r, is r equals f of k. So the best thing to make this make sense is actually to do an example. Let's look at the example of 7x cubed minus 3x plus 4, and we're going to divide that by x plus 2. So notice the connection between x minus k and x plus 2. That means k equals -2, because by definition the factor is x minus k. So if I see a positive here, it means a negative got plugged in. So let's run this through synthetic and see what happens. Synthetic substitution and synthetic division are very much the same. So we're going to set up our box. 3, oh look, 2 is missing, so I'll say that placeholder there to help me remember. It's going to go 7, 0, -3, 4. Running this through synthetic, we drop the 7, multiply negative 2 times 7 is negative 14. Bring it down, add straight down. Negative 2 times negative 14 is a positive 28. Adding down, negative 3 plus 28, 25. Multiply negative 50, add negative 46. This is my remainder. So here's the key idea. If x plus 2 is a factor, which means divides evenly. That means negative 2, that means negative 2 is a 0. Or a solution. And if you were to plug f of negative 2, if you were to plug negative 2 into the function, you should get 0 as an answer. If f of negative 2 gets you anything else other than 0. So in this case, we got negative 46. If you get anything else other than 0, that's a remainder and x plus 2 is not a factor. So in this case, when we evaluated using synthetic negative 2, we got this remainder of negative 46. So that means that that x plus 2 is not a factor of 7x cubed minus 3x plus 4. So big picture, synthetic substitution, we're now going to call synthetic division. Because we just used it to determine that negative 2 is not a factor. How would I actually write the result? Because we're saying this is a remainder. So, we did 7x cubed minus 3x plus 4. We divided that by x plus 2. So what does this actually equal? Well, when we divided, we knocked the degree down by 1. So this cubic, the result should now be a quadratic. We're going to use the following notation. This number is my constant, so I'm going to put C for constant. This is power 1. Wait, back that up. Sorry, hold on. This is my remainder, my R, remainder. This is my constant. This is my x to the first term, and this is x squared. So you can either use x's, or you could just put 1, 2. What I mean by that is that when I go to write my result, it's 7x squared minus 14x plus 25. So notice 7 is the coefficient of the x squared term, negative 14 is the coefficient of x to the first power, and 25 is my constant. See how that worked? If it helps, maybe draw some arrows. And then for my remainder, minus 46, because it's negative, and then divided by what you had divided by, x plus 2. So that is my answer. So this whole time when we were using synthetic in the past, we just arrived at this number at the far right, and that was good. That was the purpose. But now we're actually understanding that we are actually finding the coefficients we need to state the result of the division, and we will continue to practice this. So that was synthetic. Now we are going to learn how to do this same question using long division. So blast from the past, you don't have to write this one down, but I just want to remind you what we mean by that. Remember when you had a number like 256 and you said, let me divide that by 3. 3 doesn't go into 2, but 3 can go into 25. 3 goes into 25, how many times? 8, and then 8 times 3 is 24, and then you subtract it and you got 1, bring down the 6, 3 goes into 16, yada yada yada. That is what we're talking about when we say long division. But now we're going to be dividing polynomials. How exciting! So let's put our cubic function 7x cubed minus 14x plus 25. That's going to go inside the division box, so to speak. And on the outside, we will place what we are dividing by, which is x plus 2. So that setup should be familiar to us, just like grade school division. Now the way that I show you to do this, I highly recommend you use colors or a different color pen because it helps. I'm going to circle x. We start off by dividing the leading coefficient by x. So you have two ways of looking at that. You can say x times what gets me 7x cubed, or 7x cubed divided by x. For me, I think multiplication is a little easier. So when I ask myself, x times what is 7x cubed, the answer is 7x squared. But notice I don't have an x squared placeholder to write that above. So since we are all taking our notes in pencil, let's add in a placeholder. So plus 0x squared is there, and then everything else was the same. Minus 3x plus 4. And that's really helpful to line it up because when I hit this last term, I'm done with my division. So by having a place to write 7x squared, I know exactly where I stand in my process here. Now, we take 7x squared and we are going to multiply it through. So 7x squared times x is 7x cubed. 7x squared times 2 is a positive 14x squared. I'm going to write that a little neater. And now we subtract. So put this whole piece in parentheses. Let's subtract. 7x cubed minus 7x cubed is 0. That's gone. 0x squared minus 14x squared is a negative 14x squared. Now we will bring down the negative 3x. This becomes my new leading coefficient. So I circle it. The question repeats. X times what is negative 14x squared? I'm hoping we're all saying minus or a negative 14x. Again, x times what gets me negative 14x squared, or you could see it as division. Negative 14x squared divided by x gets you negative 14x. We now take this, multiply it through. So negative 14x times x is a negative 14x squared. Negative 14x times 2, negative 28x. And now we will subtract. Parentheses, minus. This negative negative turns into a positive, so negative 14x squared plus 14x squared is gone. Negative 3x plus, because minus minus is a plus, so negative 3x plus 28x, we get 25x. And now we will bring down the 4. In this case, plus 4. This is my new leading coefficient. So once again, x times what is 25x? Positive 25. Multiply that through. 25 times x, 25x. 25 times a positive 2, positive 50. We will subtract. 25x minus 25x cancels to 0. And then 4 minus 50, negative 46. I have no other terms to bring down. This is my remainder. That number should sound very familiar because, check it out, the result of the synthetic division also had a remainder of negative 46. It's going to bother me, this is a different color, so I'm changing it. Give me a second. Okay. So look, notice, negative 46, negative 46. This process, and the reason I used colors, I'm going to pause right here, we did the same exact steps, we just repeated those steps 3 times. So the neater you are with your work, the better you'll be. Now in terms of what the final answer is, it's right here at the top. So the result of the division is 7x squared minus 14x plus 25. Here's my remainder, minus 46 divided by x plus 2. Again, if you notice, I can get these on the same screen. These match exactly, which is awesome. So we have 2 completely different ways to get the exact same result. Synthetic division and long division. So those are our 2 vocab words. Synthetic division and long division. That officially ends our, let me just check my notes here. Our first example. We have one more to complete our day 1 notes. So let me get a brand new page here if I can. Let's see. Awesome. So this is example number 2. We are going to be working on 2x squared minus 3x to the 4th plus 6x plus x to the 3rd, all divided by x minus 1. We must have standard form before we can divide. So let's rewrite this in standard form, meaning highest power to lowest. So that will be, let's see, what's the highest power that you see? No, maybe, x to the 4th, no, no. So it's negative 3x to the 4th. And then next in line would be the plus x cubed then plus 2x squared, plus 6x is last, and that's it. 1, 2, 3, 4, 1, 2, 3, 4. So if you're ever not sure if you forgot one, you can just count and make sure that you have the same number of terms. All still divided by x minus 1. Let's run this through synthetic division first. Which is something we're comfortable with. If I check for placeholders 4, 3, 2, 1, I technically will have a placeholder for my constant term. Doesn't matter as much with synthetic, but we definitely will need it for long division, so we're just always going to make sure we have all places represented. My factor is x minus 1, so 1 will go outside my box. Let's pull the coefficients. Negative 3, 1, 2, 6, 0. Please press pause and run this through synthetic, and we'll compare answers when you are done. Let's check our answers. So we drop negative 3. 1 times negative 3 is negative 3. Add straight down, negative 2. Multiply, negative 2. Add down, multiply, add down, multiply, add down. So an important note, remember I had said with synthetic substitution it didn't matter, but now that we're using this process for division, need 0 constant placeholder for synthetic division. Otherwise, resulting places will be off. What do we mean by that? Well, remember before, this is my remainder, this is my constant, 1, 2, 3. So if I didn't have that 0 as a placeholder for the constant term, all of these would be shifted by 1 and it would be incorrect. So my question to you is x minus 1, this is my original divisor, is x minus 1 a factor? The answer is no, because I actually got a remainder. Here the remainder is 6. If this had been 0, then that would have told me that x minus 1 is a factor. But we got a remainder, so we were able to do the division. It just means that x minus 1 does not divide evenly. Go ahead and take a minute, or like 30 seconds, to see if you can write the result. So remember, these are all coefficients. What's the actual answer going to look like? Press pause, give it a try, and then we will see if we match. So using my little green numbers to help me, I know that this is going to be negative 3x cubed minus 2x squared. I do not have a linear term. There's no, I mean, you can write 0x if you want to, or you can just skip it and write plus 6, and then my remainder, plus 6 divided by x minus 1. Let's now run this exact same example, but through long division. So negative 3x to the 4th plus x cubed, x to the 3rd, plus 2x squared plus 6x plus 0. So we're going to keep that placeholder. We're dividing this by x minus 1. So I'm going to be dividing leading coefficient by x. That's going to be my go-to first step every single time. To start this off, my first leading coefficient I'm going to work with is this one right here, negative 3x to the fourth. So let's get those questions going. X times what is negative 3x to the fourth? Negative 3x cubed. So I put it over this spot, and because it's directly over this and all places are represented, I know that I will eventually have 1, 2, 3, 4 terms that are part of my answer. What do we do next? Do you remember? We are going to multiply this through. So negative 3x cubed times x is negative 3x to the fourth. Negative 3x cubed times negative 1 is a positive 3x cubed. We subtract, making sure we use parentheses, put the minus on the outside, draw the line across. Minus minus is a plus. Negative 3x cubed plus, negative 3x to the fourth plus 3x to the fourth is 0. That's gone. Now I have x cubed minus 3x cubed, and I get negative 2x to the third. Drop the next term, bringing that down. So I bring down my plus 2x squared. Process repeats. This is my new leading coefficient. X times what is negative 2x cubed? Answer, negative 2x squared. Multiply through. Negative 2x squared times x is a negative 2x cubed. Negative 2x squared times a negative 1, positive 2x squared. Nothing else to multiply through. I just have these two terms to multiply it by. So I parentheses, minus, draw the line. Minus minus is a plus. Negative 2x cubed plus 2x cubed is gone. That's 0. Two x squared minus 2x squared, that is also 0. So you can either choose to write the 0 or not. But we are going to now drop our next term. So again, that 0 is optional. But 0 cannot be a leading coefficient. So I'm not going to circle the 0 because that's not going to work. This is my new leading coefficient. X times what is 6x? Notice I skipped this piece because there is no x term. Remember that the placeholders line up. So 6 is a constant. It lines up over the constant term in my original polynomial. So I multiply 6 through. Six times x is 6x. 6 times negative 1 is a negative 6. Parentheses. Subtract. 6x minus 6x is 0. And then I don't really have anything, I mean, you could imagine a 0 here. 0 minus minus is a plus, 6 results. I have nothing else to drop down. Dropping down a 0 doesn't accomplish anything, which means this is my remainder. and I am done. So the result is negative 3x cubed minus 2x squared. You can choose to write the 0x if you want. I'm not going to. Plus 6, and then my remainder is plus 6 divided by x minus 1. So that completes the day 1 notes. Notice if we compare our answers, look at this one and look at this one, they are the exact same. And for those of us that like to write little side notes, I'm just going to make a mention here. No, you're done. When there's nothing left for you to drop, or if you align, or if you've lined up like terms above the radical sign, or excuse me, above the root, I don't mean to make, above, I'm messing up my note, above, I meant to say the division, so above the division bar, there's no more spaces to fill. So what I mean by that is, once I put the 6 here, right, we asked ourselves x times what is 6x, and the answer was 6. This was the last place. There was no more places. So I'm done. That was the last step. So that's it for the day 1 notes. If you would like to press pause and start working on that day 1 and 2 homework worksheet, that would be fantastic. The first half hour here has been dedicated to day 1. I'm going to continue the recording for the day 2 notes. So if you do have the time to take both sets of notes right now, continue with me. Otherwise, go ahead and press pause for today and rejoin me tomorrow or at your leisure for the second half of these notes. Starting on day 2, we are going to continue this practice, because with these types of questions, practice, practice, practice really makes perfect. So the last one we did on day 1 was example 2. Let's get into example 3. Let me get a nice fresh page for that. So this is going to be example 3. We're going to be doing 2x to the 4th plus 3x cubed plus 5x minus 1, and we're going to be dividing by x squared minus 2x plus 2. Now, up till now, you could be thinking like, man, synthetic and long division, they get us the same answer, so why could I possibly have to learn both of these if the synthetic is so much shorter? Can only use synthetic division for linear divisors with coefficient of 1. So like x minus 8, that's a linear divisor, coefficient is 1. X plus 5, linear coefficient, or excuse me, linear term of x, coefficient is 1. Anything else have to use long division. Case in point, look at what we're dividing by right here. That's definitely not linear, so there's no way we can use synthetic. So we're going to get straight to using our long division skills. Let's check for placeholders. 4, 3, missing a quadratic term, so we'll put plus 0x squared, linear, and our constant, and we're good to go. So inside the box, 2x to the 4th plus 3x cubed plus 0x squared plus 5x minus 1 inside, and then on the outside, x squared minus 2x plus 2. I know this one looks a lot crazier, but it's going to be the same exact steps. Let's make ourselves a little note. Dividing leading coefficient. More like leading term. By x squared. So let's get to it. This is my first leading term. X squared times what is 2x to the 4th? Answer, 2x squared. Notice how I lined these up, and by doing that I know exactly how many more places I need to fill. Send this back through, we're going to multiply. 2x squared times x squared is 2x to the 4th. 2x squared times negative 2x is a negative 4x cubed. And then 2x squared times positive 2 is a positive 4x squared. Nothing else to multiply, so I will put my parentheses, subtract, line all the way across, and let's do it. This cancels to 0. Oops. 3x cubed minus minus turns into a plus. So 3x cubed plus 4x cubed is 7x cubed. 0x squared minus 4x squared is a negative 4x squared. No other subtraction to take place, so let's drop. Let's repeat the process. Here's my new leading term. X squared times what is 7x cubed? Answer, 7x. Multiply through. 7x times x squared, 7x cubed. 7x times negative 2x, negative 14x. 7x times a positive 2, positive, oops, my bad, 14x squared, sorry. 7x times 2, positive 14x. There we go. Nothing else to multiply through, so we will now subtract. Cancels to 0. Turns into a plus, so negative 4x squared plus 14x squared is 10x squared. 5x minus 14x is a negative 9x. No other subtraction to take place. Drop the next term. That's my last term that can be dropped, so I know that after this step, I'm done. We've got one more leading term to work with. X squared times what is 10x squared? Answer, positive 10. Multiply that through, and we get 10x squared minus 20x plus 20. So I literally just mentally took 10 and multiplied it through these three terms. Let's subtract and see what happens. Zero. Negative 9x plus 20x is 11x. Negative 1 minus 20, negative 21. That's my remainder. So our answer is, what's at the top? 2x squared plus 7x plus 10. Plus the remainder, 11x minus 21. And what were we dividing by? We were dividing by x, right here, x squared minus 2x plus 2. So that's what goes right here, x squared minus 2x plus 2. And that's it. So that's the key idea, is that long division is our only option when we are dividing by something that is not linear, whose coefficient is not 1. And how do we know we're done? We have no more spaces to fill, nothing left to drop, and if you notice, compare the degree of what we're dividing by and the degree of the remainder. As soon as the degree of the remainder is less than the degree of what we're dividing by, we have to be done. Because ask yourself, is there anything you can multiply x squared by to get x? And that answer is a no. So that's not possible. So I know I said I was going to put all of the day 1 and all of the day 2 notes together, but I think I'm actually going to pause right here, and I will make a second video that continues on. You definitely have everything you could need to continue to work on that homework. I will make a day 2 video. Technically number 3 was the first one on day 2. But I'm going to make a day 2 video that has 3 more examples to round out the day 2 notes. Nice job so far. Any questions? Shoot me a remind. In the meantime, have fun getting started on that homework worksheet for day 1 and 2 of polynomial division. Nice job, guys.